Started. Live status.
Satvik.
Okay, started on.
Started and
Okay.
Satvik continue.
Let me just share the screen. Okay, you can see the screen, right?
Intro. Satvik will continue.
Okay.
Satvik mute లో ఉంది ఒకసారి మీరు ఆన్ చేసుకోవాలి.
Okay. So folks, welcome back to another session. Today Mr. Sriharsha joined us and agreed to do this session. So on behalf of everyone, I thank him. So Harsha sir has worked at Apna time in just as a software developer, and he was part of many projects there. We will keep his LinkedIn description and his portfolio in description, so you folks can check it out when you see the YouTube live stream. And I am sure today's session will help many people. And personally, as a first year, I am very excited to know more about DSA. So without any further ado, sir, this session is all yours.
Thank you, Satvik. Okay, let me just go to the screen. Starting the slideshow. All of you can see the screen, right? Hello?
Yes, Anna.
Yes, sir.
Yes. Okay. So basically today's talk is all about DSA in this case, where when we were in first year, like all we started was with DSA. We started with stacks, we started with queues, then we went with linked lists and all that. But the question always ran in the back of our heads, as in like, where do we actually use them? And most people just think DSA is only for the backend. For front end, it's all about the user interface. Nothing. It's only about the design. But that's not true. DSA exists in the world of front end as well. So this talk is more about giving examples on where DSA is actually used, rather than going in depth on how it is used. So like this is more about giving an examples, as in okay, this is a real world scenario that you use every day, like maybe scrolling on Instagram or watching YouTube or anything, and we don't even realize they just go so smooth. We don't realize that there are data structures behind. So this talk is more about like explaining what those data structures are that are powering our everyday use cases and how they are powering us. So I won't go much into the code examples here. This is more examples here because we wanted to keep the talk for everybody, especially for first years who haven't even completely gotten into DSA yet. So this is more about uh, giving you some excitement, as in okay, if I learn DSA well, these are all the things I would be able to achieve. So for that reason we made this talk. So welcome to DSA in disguise. So these are the all the things we cover: queues, where they are used, stacks, trees, hash maps, graphs, and greedy algorithms, and dynamic programming. So these are all the one of the major DSA topics, and DSA is also being asked a lot in interviews as well, especially the big tech. They completely hiring over the DSA now. So you might have also seen on uh, a lot of lead code, a lot of discussions on the forums, like why do front end require DSA and all that. So this is why. let's start with the story. This is the story of content, not just mobile app development, but every front end development. It can be mobile apps, it can be web pages, it can be like desktop applications. Uh, just like the Word or PowerPoint that you use, those are desktop applications. Just like that, for every front end application, the part of the application the users will see. This is the story of that application, not just for mobile applications, for everything. So let's start with the basics. So this is the very first C program that we would have all written in our the very first C programming class. And I'm kind of assuming here that C is still being taught for new regulations, but you basically get the gist. The language is not important here, but just the semantics are more important than syntax. So what this let's say at this function uh, main function, it has a main function. There is one printf statement, and it just returns. So this is a very simple main function. So what is happening here? What it does, it starts the execution at main. It comes to the printf. It prints the hello world on the screen, and it just quits. So the moment we run the program, it just prints the message and it quits. But our GUI applications are more advanced. We don't want the moment user starts, we don't want to show the user some screen and immediately quit the application. That's not what we want in the world of GUI. GUI will wait for the user to make some interaction, and then we respond to those interactions. Like those interactions could be clicks on buttons, or it can be do something with a mouse or typing something if it is a word processor, anything. So we basically GUI apps, they wait for user interaction, and they also show the UI. So they are more advanced. So let's start with the event loop. By the way, these concepts, right? Like these are not new concepts. These concepts have been present since the dawn of time. And this is an example from Microsoft Windows API, which was released for the first time in November 1985. Again, you don't need to look completely into the details, but just understand the nuance, the very high level, which I'm going to. So basically, what it does, you can ignore all this syntax here, the winmain, the API, the H instance, all this. You can all ignore completely this. Here you can see there is a declaration of a structure called MSG. So MSG is a struct. An instance of it is being declared here, and there is a loop. So what this loop does, it gets a message, and there is inside this there are two functions. There is translate message and dispatch message, and it returns. And there is one more function callback called WND. We don't need to go completely details into this, but let's focus on the so messages had declared here. They are events that are coming from the GUI, and we have in the while loop we have a function called get message. So what this get message function does is there is some sort of queue, and like it tries to get a message from the queue. If the queue is empty, it waits until somebody posted a message into that queue. Once that message is done, it is writing that message to this MSG, that is this ampersand operator. And so basically, like it says to the operating system, don't quit me yet. I want to wait until some message happens, until some event happens. And once an event happens, there are two calls. One is translate message and dispatch message. By translate is nothing but a virtual keyboards. Like every keyboard will have different manufacturers back in them. So there will be different key codes for different types of keyboards, and those keys will be translated to character values. You don't need to get into the nuances there. And then there is a dispatch message. What this dispatch message does is very simple. It just calls your WND prompt. So all you're doing is waiting for a message from which is getting posted to a queue. then you are acting on that. That's all. So what you just saw is just a queue. So somebody is posting messages into the queue, which is usually the operating. It can be a keyboard event or a mouse event or some other input event, maybe if it's controllers, joypads, or anything. An event is something which is posted by the operating system, which happens because of user interaction. And we just take that event, we process that event. So it is just a queue. So this is where our first data structure comes in, that is queue. And we use queues in event loops. And what exactly is happening here? So for example, let's just take an example with a simple key press. Let's say user presses the A character, A key on the keyboard. So Windows, it posts a WM key down, the event to the message queue. Then get message returns WM key down. It's a constant. You don't need to worry about that. And translate message, what it does, okay, it takes key down and it converts that into a character type, which is a character with an ASCII A value. And dispatch message simply calls our WND proc, which is our callback with WM key down. And get message, this is the first iteration. Once the dispatch message is done, we have already, removed this first key down event from the queue. Now queue is empty. Now, while translate message is happening, it is creating one more WM character event and it posts back to the queue. And so in the second iteration of the queue, get message will get the WM char which is posted by translate message. And now translate doesn't do anything, it doesn't require. Dispatch message calls with the character event. So this is a queue in Windows. All your Windows applications use the same loop here. Now let's see how that exists. The same event loop translates to other platforms. So this is agnostic of platform. That's what we design. It's not depending on Windows. Every other platform, whether it is Mac OS or whether it is Android or iOS or even the web, the browser, everything has one event loop. So let's see how that happens. In Mac OS, there is something called NS application that has run. By the way, if this syntax does not look familiar, that is okay. This is a language called Objective-C, and this language was released by Apple just 1 year before C++ was released. And that's why the syntax looks different, but NS application is a class, run is a function inside that class. Think of it like that. So there is a run function which is void, and basically all it does, this per syntax is nothing but a while loop. So it is a never-ending loop. And what it does is, again, there is an event. Windows calls it message. macOS calls it an event. So basically, it is getting a next event and then sending that event and updating its windows. So that is the loop in macOS. Every time an event happens, it runs. Now let's come to Android. In Android, this is a very simplified example, but the real startup happens in activity thread. But basically, Android has a concept of looper. So for every thread, there can be a looper. Whatever starts your main function, by the way, main, you don't write main, it is part of the framework. Framework will write it for you. So there will be a looper. And in the looper, there is a static function called as a loop. So basically, it just in the end, it calls looper.loop. So what it does, there is a message queue again. It is getting an instance of message queue. And again, there is this infinite loop, for loop. It is getting a message with queue.next. If message is null, then we are breaking. That means it will start blocking the thread until the next message. Now, once the message comes, it is dispatching, and then recycling it so that it prepares for the next event. Again, the same concept of queue. Here you are getting it from the queue. Who posts to the queue? That is again the operating system. So the message queue is being posted by the operating system. Any event is a message. You are basically like polling for the for events. Once the event comes, you are dispatching it, you are processing it, and you are continuing waiting for the next event. The same happens in Android. So it's the same in any front-end platform. Like queues are the very foundation of the data structures. So the very basic data structure that we use is queue. Now let's come to the stack is back. So you must have been using like multiple applications on your phone, and you move between multiple screens in an application, and then you tap on the back button to go to the previous screen. How that back button is working is because of a stack. So let's say there is navigation history, right? Now, let's say there are screens in Android, like your application has a couple of screens. There are two ways to define screens in Android. For high level, one is an activity based and the other is fragment based. If you are making an activity, you create an intent with a target activity, and then you just start that activity with that giving that intent. And OS will add the current activity into your stack. And the same, if you want to, go back to the home screen by deleting all the screens on top, you pass a flag saying clear the top, which is the top of the stack will be cleared. So how this happens is, let's say, where is this pen? Okay, so let's say there is this part is your stack. You're on, the home screen, which is this hedge. This is the home screen, and then you're starting, for this target activity. So the moment you start activity, the target activity will be added to this stack. Now, there are two things in the stack. Now you are trying to go back. What you do, you pass a second intent back to the home activity, which is the home screen, and here you are passing flag activity clear top. Whatever is on the top will keep getting clear. So this one will be removed until you get back to the home activity. So this is getting clear. So basically, this is the stack. So how the stack works, and let's continue. If there are fragments, we have an API called Fragment Manager. Basically, you explicitly call to add to the backstack, and then there is pop backstack. You are popping one from the stack, and you can completely clear the backstack. So this is how navigation works between multiple screens, and whenever there is a navigation, a stack is involved. So let's continue. And what about in the iOS? The same thing happens. So if there are screens in iOS uses something called UI navigation controller. And in navigation controller, you call the functions called push view controller and pop view controller. So whenever you are pushing a view controller, you are adding one onto the stack. Whenever you are popping it, you are removing the very top item onto the stack. Now, what about the web pages? So all the browsers have a history object in JavaScript, and from JavaScript you can call history.back or history.forward, which is the back and the forward buttons in your browser. And you can also add history like history.pushDate with whatever is the data that you want, the title and the URL. And you can also replace the state, which is like remove the current one and load a new one instead. So these are how the history works in the web. So back and forward is by the stack. So navigation and behavior of the backup buttons require stack. So this stack is our second data structure. Now we'll go to like the next data structure, that are trees everywhere. So we all like study about trees. We study about like binary trees. Then like in binary trees we have binary search trees and all that. So what exactly is a binary tree? Binary tree is every tree has two nodes. So the same concept you can like expand basically. Let's say if there are n children for a node, then that is an array. And every view hierarchy inside every application is a tree, an array tree. Basically, it can contain any number of child nodes. So let's take this small example. We usually see this part in a lot of our applications. So there is this profile answer, there is this username, and there is this like last seat as a text message. You will see this kind of sort of thing in multiple apps. So how is this done? So we are currently talking about the legacy XML. Compose is a little bit more advanced, so I'm keeping it out of the intro course, this intro talk. So basically, you basically think of this as layouts. So there is a linear layout for horizontal. So you're first doing this whole row. Then inside this row, you have the avatar, which is an image, and then you have you are defining a column. So inside a row, there is one more column, which is for vertical, which is linear layout with orientation vertical. Then there are two text views, which is the name and the last thing. So this hierarchy is actually a tree. Let's see how it is. So this linear layout, right? Linear layout is going to be the very first. It is going to be the first node. So this linear layout will be the root node of our tree. Then this root node will have two child nodes, which is the image view, which is for this profile, and then one more linear layout for these two texts. So now OS will know, okay, instead of going, you went horizontal, you draw this, then you came next, start vertical. So inside that vertical, there are again two child nodes. So these two child nodes will again be separate, the children. So now you can easily visualize this sort of like a tree. So this is how it looks. So there is a horizontal, then there is image, then there is a vertical. Inside that vertical, there are two text views. So this view hierarchy is a tree, basically. This is the structure of a tree. So every view hierarchy is a tree. Now, how do we, like understand this? All the parents in the tree are containers. Every leaf node is a separate view, which tells how to, like what to draw on the screen, what to show on the screen. And for measuring the layout and rendering. So measuring as in, if we go back here, right, you need to know like how long a text will go. And, like if there is more text, it has to, like come down basically. So what should be the height of the text? What should be the width of the text? So these things is part of the measuring phase. And then there is this drawing phase. So the layout, which is the measuring phase, and then the rendering, which is the drawing. We come across our first algorithm, that is depth first search, DFS. So if whenever we are using DFS, we do that for layout and rendering. Now, what about events? For example, let's say if we have like a button here, on user tapped on that button. So how would that event happen? again, the event happening is also part of DFS. And bubbling is basically like, if you are, the one view is not handling that event, parent will be asked to handle that event. So that is event bubbling. And they use our first algorithm, depth first search. And by the way, like a small disclaimer, in Android, depth first search is only used by the traditional view system. The modern UIs is created using Jetpack Compose, and that uses a totally different data structure called as a gap buffer. But I have omitted that because college doesn't teach us anywhere about gap buffers. That's not very intuitive to understand. But just for that, there is a data structure called as a gap buffer. How it looks in other frameworks. So we have checked how these trees work in Android. Let's see in other frameworks as well. So we started with Windows. Again, Windows is back. So in Windows also, like, there is something called as a tree. So it has, so how it does, you create one dialog. The dialog is the root node. Then there are three controls. One is for the IDC, which is an icon. Then there is this, which is, like static text left. Then you have one more text, which is again the left text. So again, basically, it also says the dialog is the first, and then it has three children. So it is also a tree in dialog X resources. Then in HTML using Bootstrap, again, you create a div element with a flex row, then which is for the row. Then you have an image, and then you create one more div for column. In that column, there are two elements for the text. So again, it's also a tree. HTML is also a tree. Now let's go with JavaFX. JavaFX is a cross-platform UI rendering toolkit that comes on desktop Java. And example of it, per row they call it as a hedge box, which is a horizontal box. So it starts with horizontal box, then there is an image, then there is a vertical box, and then there are two labels. The label is again the same as a text view. So it translates to the same in JavaFX. Now, what about in the .NET world? Again, in .NET world with MAUI XAML, it's again the same. They call it horizontal stack layout instead of a box, and it has image. Then there is a vertical stack, which is our column, and it has two labels. Basically, the structure is always the same, and the same happens with macOS also. macOS and also in iOS, where there are files called XIP, but these are generally, generated using interface builders. So you don't directly get to this, and in practice, you don't write this, but you generally do this programmatically in practice. But again, the structure is the same. So there is a view, then there is a stack view, and so the contents for brevity, because this go like very long. But again, it is again a tree. So now we come to Flutter. The same thing in Flutter as well. We have a row, then children. Children container is a container with one child is a container with an image. Then you have a column. Column again has two children, and for these two children you have text, both text. So whatever the framework that you take, the concept of UI is being represented as a tree. So that's where you use trees a lot. The events, they use the depth first search algorithm, and so you're learning about depth first search and trees, like keep this in mind. By the way, there are like advanced trees structures called avial trees and all that will be introduced to you. You don't use avial trees by themselves on regular UI development in front end, but they are used a lot in game development. For example, there is a variation of it called AABB tree, which uses the same rotations of avial, and that is used in collision detection. For example, there are in a game there are will be like thousands of entities you will be interacting with. So whether it decides what have been actually done a collision or something, there for broad-based algorithms they will be used. Again, let's continue to the next one, the maps. So maps are here. So hash maps. So where are hash maps used? Like these are the next, like data structures that will be shown to us. Okay. So basically, like hash maps, right? They are used everywhere. The most commonly they are used in preferences, but they are also used in caching. So let's continue. So in configurations, which are for like your configs, your preferences, they're used in Android. Hash maps are used in shared preferences. In iOS, shared preference equivalents for settings that is called user defaults. In web, there are three: local storage, session storage, and cookies. All of them use hash maps. And again, on web, there are every URL can have query parameters, and these query parameters are spread as a hash map in JavaScript. So let's see those also. So in Android, all you just do is you ask the context to get you a shared preferences object. You give it a name, and then whenever you are editing it, you will just like put a string, give it a key, a value, then boolean, give it a key, then value. You can use whatever types you can, and then you apply them. You write all of them in a single stroke. Then whenever you need them, you just ask your preferences object, like preferences get string, my key is username, and if that is not there, give me null instead. Then I'm getting a preference called dark mode. If the preference is not set, give me false by default. So this is how it's used in Android. For quick settings, everything is a key value pair. That's shared preferences. In iOS, it is called as a user default, and basically you get the defaults from user. Again, this is slightly different in iOS where you set a value first and then you pass for key and the key name. So basically this is you're setting username for the value of then dark mode for the value of true. And whenever you're reading it, you just read it similarly. Like let's username is equal to like default string where because the type is a string. The key is username, then the type is bool, and the key is dark mode. And whenever you want to remove something, you can just call default.remove object and give the key, and that key will be removed from your key value pair from your preferences store. Now, for local storage on web, you use the function called set item. So local storage set item, the key value. And in order to get it, you just give variable is equal to like local storage dot get item and the key. So everywhere there is this like the key value pair, and you can remove it using remove item. The concepts are like very similar whether it is Android or iOS or web. In web there is also session storage. The difference between local storage and session storage API is exactly the same. Only thing is instead of local storage you will start writing session storage. Only difference is whatever you set in session storage, they will get completely cleared when the user reloads the page. And local storage, they will be persisted. And no matter where you store the configs, there is a hash map. Now there is a use of hash map that we say, which is caching. And the most common view of cache is LRU cache. And LRU stands for least recently used. By the way, this LRU, least recently used, is also a greedy algorithm, by the way. So I'm only covering it in one place, but when you get to the greedy algorithm section, you would again have this. So where do we use this? It is heavily used in image loading for bitmap, memory caches, disk caches. For example, let's say you are browsing on Instagram, everybody is posting, like pictures. Let's say a movie came out recently, and fans are posting images of the same poster, for example, let's say. So let's say there are 10 to 15 posts with the same image. You don't want to, like download that image 10 to 15 times. What you would do is you would download the image once, and then you will cache it. You will first cache it on your disk, and then you will cache it on your memory in your RAM. And basically, whenever the user scrolls, if another post comes with the same image, for example, you don't like download it again. You will take it from cache, which is like much faster and better user experience for the users. And then there is a library called OKHTTP on Android, which is used to make network connections, and it uses LRU cache to like reuse the URL connection. So once it opens the connection to a server, it keeps the connection active. So subsequent API calls will be faster and latency is kind of reduced. And then Android framework internally uses caching for your drawables, that is your images, layouts, which is your UI files, and then the so if the multiple screens are using the same font, or it is only loaded once. The same can be done by the apps also. Like if you have any, like custom caches, you can do that as well. So Android provides this LRU cache as a class, and you can create a memory cache by instantiating that LRU cache, and you just need to override the size of function. That's all. Now, what happens in iOS? In iOS, there is a class called NS cache, and there is another called URL cache. Both of them uses, like LRU, eviction algorithm, which is greedy algorithm. Now, there is a library called STWebImage. It is used for loading remote images into web views. It internally uses NS cache for image loading. Then there is URL session, which uses URL cache to reuse the connections. Then iOS has a framework called UIKit, which is the framework that shows anything on the UI. The traditional user interfaces are built using UIKit. It has its own text measurement functionality called TextKit, and there are colors, and then there is UI font objects like fonts, colors, the same exactly as with Android. Android and images, layouts, fonts, similar to the are coming here, colors are coming here, text measurement is happening. All of them use this LRU cache, and LRU cache is implemented by a class called NS cache. And again, apps can also implement their own custom caches, and this is how you do. For example, if you want your own custom image cache, you can just instantiate NS cache, set the cost, then like expose three functions: the set function, get function, and remove. So for caching, again, this is a hash map where your string is the key and image is the value. It's a map internally. So hash maps are used in many other places too, but let's come to the next one, that is the graph. So we are coming to the next data structure, graph. So graphs, they rule the navigation world. For example, take this screen. Assume there is, like a question trivia screen. So multiple people log in, they register, they log in. Then there is a match that is happening. Inside that match, both users will be, will be asking a quizzes, and whoever gets the questions right will be able to see either the game over screen or the congratulations screen. And if the user wants to, try again or the next one, they'll again come to the trivia. Now, if you see this, navigation, you can like every screen is actually a node in a graph. So your title screen is one node, your register screen is a node, match is a node, the in-game screen is a node, game over screen, result screen, everything is a node, and your edges are actually transitions. So whenever there is an edge between two nodes, it means from one screen user can go to the next screen. So from title screen user can go to register screen, but from title screen user is not allowed to go directly to in-game screen, for example. So that's how the navigation use graphs. And they are also used in dependency injection, where dependency injection is like a very complicated topic. I'll try to keep this very simple. Let's say you have a class and its constructor requires some other objects. So you'll need to create those objects first. And let's say that object requires some other object. You'll have to create those some other objects first. So it's a kind of like a dependency. So that's how we do this. In a dependency graph, nodes are like classes or objects, and edges are the dependencies between them. And dependency frameworks are used in very large apps. Like for smaller apps, they don't make much sense. You can like manually do stuff. But the larger your app starts to get, without dependency injection, it will be like a very tough job to manage everything. So why do we use that? Like they help us instantiate objects in the right order. Then they resolve dependencies automatically. Like let's say there is you create some classes for connecting to the API. Then in multiple screens, you just like specify you need that API, and your dependency injection framework will automatically like find that API object and just assign it here. And if there will be a use case for singleton pattern, like there is any local database that you are storing data into, you only want a singleton of it, you don't want multiple databases created. So you will use a singleton pattern there, and create a singleton, pass that same instance everywhere in the app. DI frameworks can help you, and they can also help you with like detecting missing or cyclic dependencies. So missing or cyclic dependencies are a huge problem, which on large apps they keep occurring from time to time, and DI frameworks make it like very easy to figure them out. Now, for example, on Android, let's say there is a library called Dagger, and Google created one more library on top of Dagger called Hilt. And by the way, the DAG in Dagger stands for direct acyclic graph. Everything is based on graph, and what it does, let's say you have a simple class API service. There is a fetch function. On calling it, it returns some data. Then there is a repository which they have the constructor that takes an API, and because you are annotating that constructor with at inject, and then what will happen? You are having a main view model, which is a hilt view model, and this one's constructor takes a repository. So in order to have a main view model, you need a repository. In order to have a repository, you need an API service. So you'll have to start with it first. So the moment, because you are adding this inject, right? Dagger Hilt is automatically able to figure out that you will need the objects in the right order. So it creates the the dependencies like this. It tries to create main view model. It figures out it needs a repository. So it starts creating a repository. It will figure out it needs an API service. So it will create an API service. Then, okay, API service is done. Okay, let's pass this back to the repository. Repository is done. Let's pass this back to the main view model. So this instantiation is getting automated. And here we only have, like 3 layers. But in bigger apps, complicated apps, there will be layers which go like 10 levels deep, 15 levels deep. There are cases where some reach even 20 levels deep. So instead of like manually creating all those instances, a dependency injection framework will automatically like do that for you. And in order to do that, it uses the graph data structure, direct acyclic graphs, especially for this. Now let's see on the iOS, there is a framework called Resolver. It does the same thing. Again, you have an API service. There is a function called fetch, which returns some data. Then there is a repository. Repository has declared a field called API service, and its constructor is taking an API service and assigning it. So in order to create a repository, you need an API service because your initializer is taking it, the constructor. Then you have your view model. In order to have the view model, it needs a repository. So where you do that with the resolver, right? Like you are registering an API service directly, it doesn't require any arguments. Then whenever you're registering a type of repository, for API you are calling resolve. So basically like resolver will automatically try to go and find out what it can like substitute in this place, which is API service. Then you're basically registering the view model, where for repo you are telling, okay, whenever you have a repository, resolve it. So the same thing happens now. Let's say you are using resolver to instantiate a view model. Resolver will try to instantiate view model. It tries to resolve, okay, I need a repository. It will start creating a repository. Okay, I need an API. It will start like instantiating an API. Then use that, finish constructing repository, then finish constructing the view model. So this is the same approach in iOS as well. So similarly, like this dependency injection happen in multiple frameworks also, but I'm not covering them because like that will start getting code hit. We only want to like keep this talk to just let people know that there is something like this existing. So in Android, so people use, there is Dagger. Then Dagger is slightly complicated to use, so Google created a library called Dagger Hilt, which is a simplified version of Dagger. And there is one more library called Coin, etc. There are multiple other frameworks, but these are the most popular ones. Then in iOS, people use Resolver. Then there is Needle. Then there is Widget, etc. And the same happens in JavaScript as well. Like Angular, which is one of the popular UI frameworks, it has its own, like the strongest dependency injection system, where in Android and we are using an annotation called inject, but in Angular JavaScript, it will be called as injectable. It's just a small name change, but the concept is exactly the same. So everywhere in frontend, the dependency injection, you will be using the graphs as a data structure. By the way, this same dependency injection, Dagger, for example, is also used in backend systems in some places. So yeah, the graphs, it translates. This is where you use graphs. Now, if the graph breaks, your app crashes. Now, let's come to the greedy algorithms. Where are these used? Now, one biggest case is image loading. By the way, you don't need to worry from now. From now on, there won't be any like code examples. So image loading is one use case where greedy algorithms are used. For example, like image libraries, right? They often pick the closest and smallest possible image that satisfies this cluster. Let's say, you have, like your own profile. You are uploading your profile to Instagram, for example. Let's say you are taking your camera and you are taking your picture. Whenever you are using a camera, the picture, like it gets created in a the full length, whether it is portrait or landscape. It has too many pixels, and then your, Instagram or it will ask you to, like crop that image to a square. And let's say you are cropping it as a 1024 by 1024 pixels. And once you set the profile picture, it is only shown in a like 128 container. Like that image is a huge image is being shown in a small place. So what needs to happen? It needs to be like resized. And so let's say in the screen, if it is only being shown in a 128 by 128 container, then image loading libraries, image loaders, they will resize that image and only keep the resized image in memory. They will not load the complete image. They will load the resized image. So for a full image uncompressed, it will take around 4 megabytes of RAM. Then for the resized image uncompressed, it will take about 64 kilobytes of RAM. So for this one, it always goes for the smallest size that is required, and that is why greedy algorithm for image loading. Then infinite scrolling. So you have Instagram again. You will be like keep on scrolling, keep on scrolling. Most of the users, they don't keep 100% attention on one post. They'll keep on scrolling, and it takes a bit of time, in order to fetch the next set of posts. So what happens? Let's say user scrolls down 80%. Instagram will automatically assume that the user will, ask that remaining 20% as well, and it will start loading what happens after that 20%. So this ensures, like a smooth, no wait scrolling. Because we don't want to, like any social media app, they don't want to lose the attention span of users. So they will do load the next post what are supposed to come in the background. So it will be easier for the users. So it is another example of a greedy algorithm. Now in networking, so let's say one great example is analytics. So why generally we have analytics is once your app goes on to the production, right? There will be some thousands of users, millions of users. What will happen? Let's say it starts breaking to like 5% of them. It's still a huge number of users that it is breaking for, and you need to know where exactly is it breaking. What is the user journey? So because of that, people statements, and these log statements analytics are being sent over a server. So you will be able to see them. There are services like Firebase, Crashlytics. There are other services like this. Then Basics Panel for analytics. Then there are some other companies, they create their own in-house things for analytics. And user is, like frequently going through a function. And in a span of a second, people can, go through some 100 functions, let's say. Functions can automatically get called in the background. We don't want to make 100 API calls just because user tapped a button. So that will be, reducing all our bandwidth on the backend. So in order to do, we do rate limiting or throttling. So what we do, usually it is like, either the 100 events. Once 100 events are done, like we will start pushing all the 100 events. Or let's say, okay, from the last push, 10 minutes have happened. So whatever the events we have so far, we will send all of them back to the server. So this is how analytics are being sent, and this is called as a batching. And this is a greedy algorithm because it has only two things: either 100 or 10 minutes has elapsed, which is a greedy step. We don't, like try to specifically optimize for like what if 10 of them have been say, already seen by the backend, or five of them have already been seen. We just apply the same rule, hoping it optimizes for everything, and that is a greedy algorithm here. The next greedy algorithm is a location-based optimization, and this is usually seen in food delivery apps, like Swiggy or Zomato, etc. So let's say there is a restaurant which has many branches. There are usually restaurant chains like that. So your app will automatically select the branch which is closest to your location. So how it does, it computes the distance to all the options, and it just picks, like what is the distance which is the smallest distance. That's all. So this is a greedy algorithm. It just, like pick the smallest distance. Now, the same greedy algorithm is being used in Bluetooth or Wi-Fi selection as well with the best available network. Let's say, you have multiple saved networks, multiple saved Wi-Fi's, one in your, house, one, like in your office, one in your, one in your, your friend's place. What it does, and then there is always this, like mobile data. This is, like handled by the OS itself, but in some cases, your phone app will also choose for a stronger signal. So it tries to pick the network which has, like the highest RSSI. Basically, it means the signal strength, like highest signal strength in a short time. And what is that network? It will start using it. And the benefit is, once it picks and which has an acceptable, signal strength, it will not start trying each and every other network, and this is used as a battery saving optimization as well. So this is another use of greedy algorithm at place. And how phone app does it is, let's say you have, a 4G enabled SIM, whether it is Jio or Airtel or something. There is something called VoIP, which is voice over IP. And voice over IP can happen. Basically, what will happen? Your phone call, instead of a regular phone call, it happens through internet packets, IP packets. And when your carrier supports VoIP for a highest voice clarity, if there is a Wi-Fi which has a higher strength, it will go over Wi-Fi. And if you don't have a Wi-Fi, then it will start using your mobile data. This is the case for Jio and Airtel today. So your phone app, which makes the calls, does this distinction. One more example of a greedy algorithm. Now, there are greedy algorithms in layout optimizations as well. As I said, there are measurement phase, right? Like give each component the smallest space it needs first. So for a second, I'll go back to the previous slide where, I have this user. So here there is this text, right? There is this text, there is this image. For this text, we are basically specifying it as the wrap content. Basically, what it means is it needs to, measuring how long will the text take and how long will the, what is the height of the text on each dimension, and then assign that to the text view. So how it does, is it starts with the very smallest value, and it will ask the renderer, okay, is your text fitting inside this text? If not, it will try a little bit. Then it will ask, is it fitting now? Is it fitting now? Is it fitting now? And this is there is a concept called, like the intrinsic sizes, which is what happens here as well. So I think yes. So looks like some network issue. Yeah. So like wrap content in Android uses that. In iOS, it is called as an intrinsic size, and in Android, iOS, and web, there is something called flexbox layout. It uses the same intrinsic sizes, the greedy algorithm for distributing the flexible width. So this is another example of greedy algorithm. By the way, where do you see this flexbox, this greedy distribution of width? Is in filter panels. For example, in Swiggy, there will be filters, horizontally scrollable filters with chips and all that. That is a good example of this flexbox layout in example. So greedy algorithms are like almost everywhere. You just need to like look for them. Now comes another topic, the dynamic programming, and a very good case for dynamic programming is text rendering and line breaking. Like let's say, take the mobile phone or a web page, right? Not everybody has the same size of the screen. Like each and every phone comes with, like different screens. OnePlus phones have different sizes. Phones have a different screen sizes. iPhones have different screen sizes. Then there are, like web pages which are running in tablets. They have a different available space. On a laptop, there is a different space. On a desktop PC, there is a different space for web pages. So whenever there is a text, your browser or your renderer or your application, it should know where, like it has to skip to the next line. And like how are paragraphs formatted. So how this happens is there are two main algorithms, majorly used algorithms. Both of them use dynamic programming, by the way. So one of them is Knuth-Plus line breaking algorithm, and the second algorithm is word wrapping with minimum penalty fits. And both of them are used to compute optimal, like line breaks that minimize variance. You know, character is cut off from screen. We don't want that, and it also used to minimize the bad spacing. Like let's say there is a space after this, but your screen is exactly until A. After A, there is actually a space in character, but this algorithm will decide to, like not render that space next line. So this L character starts matching with this because you will be able to understand without an extra space which is coming to the next line. User will be able to understand that okay, there is a word break that these are two different words. If there is one more space, it looks odd here. The same happens for paragraphs as well. So this is one place where dynamic programming comes into picture. One more use case is your autocomplete and keyboard suggestions and autocorrect. So let's say the moment we wrote a word, you tap space, your keyboard will start showing, like your next likely to be used word. You can see this in Android and also in iOS. So how does that work? And let's say you start typing something, you mistype it sometimes those words will be auto corrected with the correct spelling for you. Sometimes a red color wavy line will be shown below them. So how do that work? So there are algorithms again which are using dynamic programming here. One is the Viterbi algorithm, which is used for sequence decoding. And then there is one more thing called Levenstein distance for fuzzy matching. And there is a data structure called trie, which is used to correct the typos, spelling checks, and autocorrect, and also for keyboard suggestions. So this is how like dynamic programming comes into picture. And so yeah, now let's say it is also used in layout constraint solving. The layout that we first saw as an example are like rows, columns. So it is a multi-layout. What if you don't want multi-layout? You wanted like define it based on constants. You can do that. In Android, there are layouts like constraint layout and motion layout, which is the animation, by the way, animating. And in iOS, there is something called auto layout, and both of them use dynamic programming for solving the constraints. You don't need to know exactly right now what those constraints are, how that works, but just know that like they are based on dynamic programming. And the algorithm, the constraint solver they use, very constraint solver. By the way, if you are like really curious, the Android source code for constraint layout is actually present in open source. You can go to cs.android.com and start reading the code if it makes a little sense. If you're feeling a little adventurous, but it's not mandatory. Just know that like dynamic programming. This is a there is a concept for layout constant. It uses dynamic programming, and there are many more cases as well. For example, you open Google Maps. You go from one destination to another destination. Real time traffic. So let's say there is too much of traffic. Google Maps will say, okay, there is a slowdown of 10 minutes on this route. There we found a faster route for you, etc. So that uses dynamic programming as well in real time with real time traffic data. Speech to text translation that uses dynamic programming, and there are multiple other use cases. They use the same technique called dynamic programming. And one more bonus slide for you. I mentioned that there is something called gap buffer, right? It is being used by Jetpack Compose. By the a gap buffer is also used by a text renderer. So let's say like there is text, a huge wall of text. User tapped in between that and started typing out. In order to efficiently insert the text, and in order to efficiently delete the text, there is a data structure called gap buffer. And this is a very old data structure. This is used everywhere in text editing, including your notepad on Windows that uses a gap buffer. Any text editor, modern text editor uses a gap buffer. The place where you are writing code, your Vim, if you are using Vim uses gap buffers. If you are using Nano, if you are using uh, an IDE like code blocks or anything, any text editor uses gap buffers, and that includes your text field inside WhatsApp. This is one more data structure to keep in mind. So we are kind of at the end of the presentation. So remember, whatever you use, DSA exists in disguise. Everything is powered using data structures and algorithms. So if you have any questions, you can ask them now. Hello.
Am I audible?
Yes, yes.
Okay. Thanks for a wonderful session, Anna. Okay. My question was how if you are joined to a job what are the main advice you will give to a DSA learning student? What should they
Hmm.
prepare?
So every big company, they do ask for DSA. Like very young startups might not ask for DSA. They just need like development experience. They just need people who can use already existing libraries and all that. Big tech and the bigger MNCs and all that, they will focus on DSA. And the reason is frameworks of today might not be like sufficient for tomorrow. For example, like before 2016, nobody thought of there needs to be something called as React. It was released by Facebook in 2016 because Facebook required it, and then people started using it. So there was a similar project in 2008 or 2006. I don't exactly remember the year. That was called Mithril JS. It was a very similar project, and like the concept is actually the same thing. Somebody required something, they built it, and you never know. Like Google, which is completely like supposed to do the Android, they own Android, but Google still like makes applications for iOS as well because the market is there. And just because Google didn't want to invest in double effort, do for Android development and then do iOS development, they created something called as a Flutter, which is a cross-platform thing. Now they're coming up with a better framework. They're pushing KMP, Kotlin multi-platform. And you never know. In future, maybe you will be the one to create a new framework altogether. So the basic understanding of data structures and algorithms is always beneficial from the point of from the job perspective. And how deep to go this again depends on your if you are like in the first 2 years, I would suggest just be able to solve easy problems and some medium problems on lead code should be fine. If you are into third year and into final year, then start getting into hard problems as well. So should be like mostly be enough for jobs. But at the same time, people always like get into this question, like, do you need DSA development? That's actually the wrong. Actually, need both of them. It's like you need to know development because development is what like companies will require in the end. But DSA will make it easier for you to learn development. It's like the stepping stone. You cannot have only one without learning the other. So focus. I would say if you are in the first year, focus your time on DSA. Second year, also you can start exploring development. By final year, you should be have 50-50 of it. 50% should go to your own development, like create your explore more projects, etc. And 50% of the time still keep practicing DSA, so you will start thinking about problems in that problem solving mindset.
Okay, what are the common mistakes like we are attending an interview on DSA? What were the
Hmm.
topics we have to learn and mistakes we will do like a fresher attending a DSA interview?
So one of the main mistakes that I have seen people do is like they uh, one thing is to keep in mind that the interviewer is kind of in front. Like your interviewer also wants to see you solve the problem. So there will be times like we will also be giving hints to things. Only thing is you need to keep a calm mind. Don't rush. don't jump to a conclusion. First, read the problem statement first. What is the statement that needs to be solved? Then do a couple of on hand. Like if you're a code editor, for example, let's say, create a comment. In that comment, like bring up scenarios. What to do in this scenario? What to do in this scenario? Start thinking out loud. So whatever you are thinking, say it out loud. So your interviewer will always be on the same page. We will be able to, understand your thought process. So where your thoughts are, that is one thing. So one of the biggest mistakes people do is they get tense. They get, stuck. Once they get stuck, like they start confused. They stop talking anything. They stop communicating. They just sit there thinking about it. If you're totally okay, to ask an interviewer to give you an example. It's totally okay. I have done that in interviews of big companies. I did that in an interview with PhonePe where I'm working now. I did that in my interviews with Google. I got that as well. It is totally okay to ask more questions when you don't have enough data. That is one thing. Another thing people do is not just in interviews but in the way people practice. People, especially the main problem is you will directly jump into lead code, see the problem, then go into YouTube, find a video that explains the solution, then do it. Okay, you're done. No, it doesn't matter if not like you need to create a story out of the problem. Like what exactly is being asked there, or how much did you comprehend the problem in the first place? Then like what are the things that you need to actually solve it? Then come up with a solution. Then is that solution an optimal one? For example, let's say for sorting, let's say there is a case of sorting, very basic example. In in an interview, you can just say to the user, you don't need to, interview, you don't need to specify what exact sorting algorithm that you use. Just say, I'm using a sorting algorithm on this. So you don't need to specify. If the question is some other thing, a high level problem, and that needs a sorting, you can just say I'm sorting this. And for sorting, I'm assuming a sort function which has big of n log n as the complexity. You don't need to specify which exact algorithm it is, as long as like you are okay with the complexity. So the trade-offs also matter. So these are the some of the main things. And when it comes to practice, it's not that like you take one topic, 200 of problems there, thousands of problems there. It doesn't come around like the number. Like I over all this is I started like doing DSA almost 10 years ago. On lead code, if you see, I max mostly would have solved around 500 or 600 problems, not more than that. It's more about how much you grasp it also. Like instead of just taking one topic and keep doing a bunch of things, start like do at least just one problem a day. Like lead code has like problem of the day concept. Just do one problem a day. That should be like more than enough if you properly understand it. And it's also like okay that like you won't get a problem on your first try. So first, when you are learning phase, right, take 5 minutes of your time just to read the problem statement. The problem itself will be giving 2 or 3 examples on lead code. Read the example, then like see the input, analyze the output, so you properly understand whether the input and output are proper or not. Then start like come up with a solution. It's okay if you do not immediate solution, take up to 20 minutes, that is fine. If you still did not get up to 20 minutes, look at the tags on the lead code. So it will help you point out in which direction to go, whether this is like should go in uh, is this an interval problem, or this is this like a sliding window. You will get an identify on like what technique that you have to use, whether this is related to graphs or reasoning. Then you can like start thinking on that and start building a solution. Once you if you still cannot solve it after 20 minutes, then it is okay to go to YouTube or any other place, a video, learn about it. Sorry, look at a video about it. That is also okay. Even after you take a break, don't immediately rush into it. Take a break, then watch the video entirely. Don't code along with the video. Like watch the video entirely. Make sure you understand it. Watch it 2 to 3 times. It's okay. Take a gap of half an hour, and then without watching the solution, solve it. Try to solve it yourself. That will like helps you ensure how much of it do you remember, basically. How much of the problem solution that you learn, how much of video that you watch you remember. That is one thing. This is how like I usually go when preparing for DSA.
Thank you, Anna, for answering my questions. Guys, any questions from you?
కంపెనీస్ ఎంత ఎక్స్పెక్ట్ చేస్తుంది అంటే డిఎస్సి అనేది ఏ లెవెల్లోనే ఎక్స్పెక్ట్ చేస్తుంది కంపెనీస్ అనేది?
Depends on the type of company as well. If it is a startup, ఒకవేళ చిన్న startup అయితే కనుక they don't expect too much. They mostly expect on how fast you can create user level features and ship the features to the users. ఎంత తొందరగా మీకు బిజినెస్ ఇంపాక్ట్ వస్తుంది, అట్లీస్ట్ ఈవెన్ ఇఫ్ ఇట్ ఈస్ ఇన్ అ బగ్గీ స్టేట్, how far can you like deploy it to the users. అది ఫస్ట్ చూస్తారు. That's the biggest one in this case. So let me just stop the presentation first. Yeah, better. That is the like the biggest use case. If it is an MNC is slow ఏమవుతుందంటే, if it is a product MNC is slow, they don't expect you to write production level code as a first year. In fact, big MNCs, especially Google and the places, it will take at least a year or two for your code to go to production. There will be too many checks on you, so it will keep on doing. So for those cases, అలాంటి companies లో what will happen is they will expect a lot on the DSA, and they will expect people to, because DSA వచ్చింది కాబట్టి they will expect because of DSA they will use students will also be able to do on the development also. It's like it's not either DSA or development, it is kind of both. Exception is very young startups so they only focus on development. DSA comes at a very later phase once the startup is not on the survival path. And for most of the companies, even for the big tech also, there is a concept called hiring levels. So there is L1, L2, L3, L4, etc. And Facebook has E4, E2, E3, E4, etc. There is a website, levels.fyi and చెప్పే website ఉంది. So depending on that, for most companies, lead code easies and lead code mediums are enough. For L3 and L4 and more than that, there you will require may have lead code hards and lead code very hard. And more than L4 మీకు ఖచ్చితంగా సిస్టమ్ డిజైన్ అనేది కూడా వస్తుంది. లైక్ ఇన్స్టెడ్ ఆఫ్ జస్ట్ ఫోకసింగ్ ఆన్ వన్ ప్రాబ్లమ్ ఎట్ ఎ టైమ్, యు ఆర్ సపోజ్ టు డిజైన్ అ హోల్ సిస్టమ్. లైక్ హౌ వుడ్ యూ డిజైన్ అ సిస్టమ్? సో అవి కూడా, బట్ ఫ్రమ్ ఫ్రెషర్స్ సిస్టమ్ డిజైన్ అనేది ఎక్స్పెక్ట్ చేయరు until you hit at least like 2 to 3 years of experience. System design is not expected from candidate.
So guys, any questions? So that brings to us to an end of our session. Once again, thank you so much, sir, for being more.
Thank you. The pleasure is all
Thank you.
mine. It was nice
Thank you, sir.
interacting with you folks.
For clearing your doubts, you can message to Sarino Discord or LinkedIn for any doubts. So don't forget to like and share and subscribe to our channel, and don't forget to hit our bell icon. Okay, thank you.
Thank you folks. Bye bye.
Nice.
Thank you, Anna.
Thank you.
And SAR's Discord LinkedIn ID